Okay, I'm Sean Gilligan, and I'm going to talk about a new library called this is the best name ever, secp256k1-jdk. and bitcoinj, which many of you are probably familiar with, and sort of the general Java and Bitcoin ecosystem, JDK ecosystem. So first of all, why do Bitcoin people give Java no respect? How many people know who Rodney Dangerfield is? A couple. His famous line is, "I get no respect from nobody." I just think that Java is pretty widely used. There's some pretty popular applications that use it. Java has a deserved bad reputation for being really verbose back in the early 2000s. But it's improved considerably, and I think that Bitcoin needs, well, so you guys know Bitcoin, and some of you may know the Duke character from back from 1995. Well, they need each other. Java is a major language. It's used on Android. It's used on servers, and Bitcoin deserves to have really good support on Java. So for those of you who haven't been paying attention, Java has changed dramatically in the last 10 years. I started getting involved in Bitcoin about 10 years ago, and I wanted to use the Groovy language, which is kind of like a Java++. And I started realizing that I was better off just using Java. You know, in 2014, Java 8 came out, and that added lambdas, and they've really changed their release schedule. So they have a new release every 6 months. Every 2 years now, they're doing an LTS, long-term support release. So we had Java 8 in 2014. We had 11, 17, 21 just came out last year, and next year we're going to get Java 25. And the years are going to finally exceed, the version numbers are going to start exceeding the years. So they have this new system where something comes out every 6 months, and if your feature isn't ready, for the different teams working on it, you just miss the boat and you have to wait for the next release. This has worked really well, surprisingly well. So I'm just going to go through really quick Java, and I put the features to the LTS releases, not the individual releases they became available on, just to keep it simple, because most people pick an LTS release and use that for their application or their library. So Java 8 added lambdas, streams, default methods and interfaces, and an optional type. Oh, how many people here are Java developers? Everybody? About half. Rust? C++? What other languages? C? Okay. I'm a C programmer at heart, but I switched, but I do a lot of Java. So I'm going to compare a little bit to Rust. Rust has an option type, so you guys, I think everybody knows it. C++ has one too. JDK added completable future, which is sometimes like a promise in other languages. A new time API because the original one sucked. JDK 11 added a module feature that does much greater encapsulation. A new HTTP API, support at the for reactive streams. It added a var type. JLink is a nice tool that lets you build a custom JDK to that actually has just what you need, and you can bundle your application with it. I believe Sparrow uses that. A lot of the Java Nix packages use that. So they have basically a bundled JDK with their app. 17 is where things start getting really fun. You have switch expressions, which is a functional switch that returns a value. Records are a nice non-verbose type for storing immutable data. Sealed classes let you they're kind of analogous to Rust enums. You can now have You can now have a number of subclasses or sub-interfaces, and you can do a switch based on which one it is and have it be exhaustive. This also supports pattern matching. JD17 added the packaging tool for bundling things, multi-line text fields, text variables, text blocks. Hex format, why the fuck wasn't that there from the beginning? They finally added that. 21 added virtual threads, which are similar to Go routines. Pattern matching and switch. Snippets in your Java code. Sequence collections is just a cleanup to the collections API. And here's the one that's near and dear to my heart. It's actually in Java 22, which shipped 2 months ago. It's called Panama, and it's a new API for foreign function and memory access. And as you'll see, I'm using it to access the secp256k1-C library. The other thing that's great for conference talks and college classes or scripting is this new feature called implicit classes and instant main, which lets you just have void main right at the root of a file. And you'll see that in an example that I have. And they're doing continued work on the virtual threads with structured concurrency and scoped values. There's a vector API, which will be used for AI. And there's also something coming. It may not make JDK 25, but I hope it does, which is called value types, which will let you, it kind of makes you write, it allows you to write your own primitive types, essentially. And it's a performance. And there's also all the GraalVM native stuff. And Java tends to be good about backward compatibility, but they're actually removing some things. Most notably, applets are gone. Another thing that some people don't know is that Java actually had a secp256k1 curve in it, and they removed it in Java 16. The reason was they thought their C implementation was flawed, and they made a pure Java implementation that relied on specific math that doesn't work for that curve. I don't think it was any conspiracy theory behind it, but if there was a conspiracy, I didn't hear about it. Okay, so anyhow, that's my. So I'm going to talk about secp256k1-jdk. This is a new project that's in the proof of concept phase, and it's under the bitcoinj GitHub organization, but it's completely separate from bitcoinj at this point. It's designed to have minimal dependencies, and we do expect bitcoinj to migrate to it. I've had some conversations with Craig Raw from Sparrow, and he's interested because the secp256k-C library used to include Java interfaces, but they were a pain in the ass to maintain, and so they were removed. So what we're doing with secp256k1, oh, I guess I'm getting ahead of my slides here. No, I'm sorry. So there's an API. There's 3 jars, three library files. The first one just implements the secp API. It's very similar to the C API, but it's simplified a little bit for Java. You don't do pointers to fields that you fill in. It just returns values. It's pretty much a functional style where, it actually uses, it returns a single value, which can be an error or a value, and you have to check it, much like Rust typically does. It's conceptually similar to the C API, so a lot of thought went into making that API, and this leverages it. And we're working on 2 implementations. The first one is secp256k1 foreign, which uses the C library underneath using Panama. It requires that you use Java 22 or later. So that may limit its use for some applications, but I think it's the right path going forward. The second implementation uses the Bouncy Castle library, which is very popular. It's what most bitcoinj apps are using It's what Sparrow uses for ECDSA. We're hoping that we're planning on implementing Schnorr on top of Bouncy Castle, but for currently, if you want to use Schnorr, you have to use the foreign implementation. And if anybody out there wants to take one of the existing JNI based implementations and implement this API, that would also be plug and play. You're able to write an app or a library that just depends upon the API module, and then at runtime, you're able to configure which implementation you want to use. Everybody knows what secp256k1 is, I assume. And Bouncy Castle is a long-standing Java library that implements a whole bunch of crypto, including elliptic curve and the secp256k1 curve. Oh yes, Alligator Swift is another thing that's missing from Bouncy that's in libsecp. We'd like to see things like bitcoinj support the new v2 P2P layer, and so there's a route to doing that. So the API design goals were to provide an API that's that supports all JVM, JDK, Java use cases. The Java VM, Android, native compilation with Graal, and can be used by other languages in the JDK ecosystem like Kotlin or Scala or Clojure. Like the C API, it's a simple API that's dedicated to Bitcoin style applications, and that's hard to use wrong. The native implementation has the design goals of using Panama, which gives you the advantage of not having to maintain any C code that adapts. The FFM library API itself provides the mapping between Java and C. So it's really nice. You're able to just take your Java app, and as long as secp256k1 dynamic library is in your path variable, there's a couple different path variables you can use. It'll automatically find it and use it. We want to be high. We want high performance. We want security, and I'm really hoping to get Sparrow on board. For Bouncy Castle, it's going to be pure Java, and should support a lot of the backward compatible use cases, particularly Bitcoin Wallet from Andreas Schildbach, who's the lead developer on BitcoinJ. I'm the junior contributor. These jars are pretty small. The API jar is 12 kbytes. The foreign implementation is 92. That doesn't count secp. And the Bouncy Castle, it's hard to say because it's incomplete. And so here's the we're currently targeting JDK 17 for the API and for Bouncy, but we may push that back to 11 if there's a reason or strong demand for that. Okay, so who's going to follow along on Replit here? That's what they told me everybody wanted to do. Wait a minute, I guess I should show you the link. Does anybody want to follow along or no? You're just going to what? You're going to do it? What did I just do? I need to option click on this. Can you see the URL? I didn't do this very well, did I? Can you read this URL up here? It's replit.com/@Sean140 /schnorr-secp256k1-jdk-jbang. That's a capital S for Schnorr. Everything else is lowercase. It's replit.com/@Sean140/Schnorr with a capital S -secp256k1-jdk-jbang. So this uses Nix to pull in everything that you need. So this is the Schnorr example here. It's written using Java 22, and it uses this preview feature of the where you can say void main directly in the file. It's called an implicit class with an instant main. Notice there's no arguments passed, and there's no class wrapper. Because of the dependencies, I'm using this command line tool called jbang, which takes these deps comments, which will load the comments. So we're loading a no-op implementation of the logger. We're loading the secp API and secp foreign. We call this method in the API to get the default implementation, which in this configuration will be the native wrapper. That creates a secp instance. We get it, and this is basically the C example ported. It's a little shorter in Java than it is in C, but we create a key pair, we get a pub key, we sign the message, we then serialize everything, deserialize it, and call verify. And if you click run, it takes a while to load everything. But if you're running this on a local system with everything installed, it runs in under half a second. And I've actually compiled this to native code using GraalVM, and it runs, I think, in about 15 milliseconds. That's pretty fast for spinning up a Java application from the operating system. There's a little bit of, you can't do it yet on ARM. The calling native C from natively compiled Java is probably will be final by JDK 25. So this is cutting edge stuff. So you can see here that jbang is installing JDK 22. It's resolving the dependencies. It actually does a compile the first time you run it, but after that it'll run. And here you go. You've got your secret key, you've got your public key, and you've got your signature, and the signature was verified. Did anybody else manage to run that? Yeah, thumbs up. One, two, just one other person? Okay. Well, I'm glad this took me some time to get together, and thanks to Cody for his help. So, how many people here have used BitcoinJ? One? Okay. There were a bunch of people when I almost gave a talk at 11:30 this morning that had used it. I guess we lost them. So BitcoinJ's been around for like 12 years now. It came out in 2011. It's mainly an SPV wallet implementation, but it provides fundamental classes for Java. It's not a full node, and it has some of the scariest comments I've ever seen written by Matt Corallo saying, like, abandon all hope, ye who enter here. If you ever try to run this as a full node, the universe will get sucked into a black hole and you'll burn in eternal flames. It did previously have a JNI implementation of secp used to speed things up, but that was also, as the story is with secp and JNI, it was hard to maintain, so we actually removed it recently. Nobody was using it anyways. So Bitcoin Wallet was the original Android wallet, Bitcoin for Android, that came out in 2011 by Andreas Schildbach, who's the lead maintainer. Bisq, the Bisq application has been using Bitcoin, a fork of BitcoinJ. I know they've had some complaints about BitcoinJ. I'm hoping these newer releases will address them. I've written a JSON RPC client that uses Bitcoin J types in the Consensus J project. I also wrote a kind of a reverse proxy server for Bitcoin Core that's, you could kind of build a, like if you wanted to build a, what do you call it, a viewer, an indexer kind of thing, you could build it on top of that. I previously worked for the Omni Foundation on the OmniJ client library, and there's a bunch of Dogecoin, Namecoin, and other Bitcoin-based forks that have been based on Bitcoin J. And some of those people have even been nice enough to contribute upstream. The main components of Bitcoin J are a core library. There's a tools directory. There's a command line wallet. There's a JavaFX sample GUI wallet that you can use as a starting point. And there's also this forwarding service tutorial in the examples, which I'll show you some code for. I did not make a replit for that. You can see that after Mike Hearn left, things kind of stagnated for a little while, but we really picked up development in the last couple years. Oh, this is back to the history. Yeah, so Mike Hearn released Bitcoin J on March 4th, 2011. And within 4 days, Andreas Schildbach had made an Android wallet using it. He burned the midnight oil. It started with a lot of people at Google doing it on their 20%. So if you look in the, in some of the copyright messages, it actually says Google. Mike Hearn handed off to Andreas when he left Bitcoin in 2016. And I will say that working with Mike on Bitcoin J was a pleasure. And he, although he did leave Bitcoin, he did hand off the project very professionally and has continued to answer any questions or whatnot when we email him. So the forwarding service example is sort of like an echo server, but for security reasons, we did it as a forwarding server, even though it's an example, but people like to have good security practices. So you basically run it. It displays an address that you can send coins to, and you configure it with an address to forward them along. So it waits for a transaction, and then as soon as it confirms, it sends it on to the forwarding address. So it's the kind of example we point people at when they want to start out. So you basically check your command line parameters, and you create a forwarding service object. You run and you wait until the thread terminates. There's a class called Wallet App Kit that you can use to spin up a wallet, and then you just add some completable future-based listeners to listen for the incoming transactions and to relay them. And those interfaces were previously using Google Guava, but because we've been working to remove third-party dependencies, and because JDK 8 added the completable future async interface, we migrated to that. What's in the future for Bitcoin J? Release 17 is 0.17, just went alpha 4 earlier this week. Andreas released it, and we're hoping to finalize it pretty soon. We're pretty much down to the last couple issues. Release 17 has this refactoring where we're kind of breaking it into 3 modules, but we're leaving them together temporarily. In 18, they'll actually be separate. And there's a base module which has 0 dependencies. There's a crypto module which currently depends on Bouncy, but will depend upon the sec. We're going to try to migrate to the secp256k1, and I think Andreas and I are agreed on that. We're still working on some of the details up for the plan. We're definitely looking for people to join in and help, and we're getting some enthusiasm from people to do that. Taproot and PSBT are on the radar. How can you help? Star us on GitHub. Use it in your project, report issues. submit pull requests, documentation improvements. We love to get those. And if any companies want to sponsor BitcoinJ development, I think it will really benefit the ecosystem. You can find me on, this is left over from my talk at SF BitDevs, but if you ever come to SF BitDevs, you can talk to me at House of Shields. But feel free to email me or follow me on GitHub or Twitter and message me. The one thing that I'm really pushing for is to try to get this secp API to get people to really review the API and get that solid so that it can kind of be the one that the whole Bitcoin JDK ecosystem uses. I think there's a need for it, and the preliminary feedback I've gotten has been positive, and I think it will greatly help. So please, if I'm going to be reaching out to different people to try to get them to review it and give their feedback, because that's it. That's the first major step, is to finalize that API. We have an unofficial release now, 0.0.1, and we're going to just keep moving forward with that. But the Schnorr sample works, the ECDSA sample works, and we've created a branch on bitcoinj to start testing it out and making sure it passes all the unit tests and things like that. That's all I have. Any questions? Thank you.